I've been trawling through some past papers. I got to AQA June 2018 paper 2, and question 6 stood out as something that really needed kind of addressing. It was a nasty looking question. It's finding the stationary point of this unpleasant looking function. It's got an implicit field to it, i.e. we're going to have to differentiate this implicitly. So before we actually do that, we need to expand x plus y minus 2 squared. So this gets a little bit kind of long and messy, but let's go ahead and do it. X squared plus xy minus 2x, and that's dealt with the first thing, and then multiplied by y, so we've got plus xy again, plus y squared minus 2y, that's dealt with that, and then we get minus 2x, so we'll put this over here, minus 2y, and then plus 4 at the end. So we can kind of almost add the like terms. So let's dealt with this one. So we end up with x squared plus 2xy minus 4x. That's dealt with all of that apart from plus y squared, minus 4y plus 4. And we know all that is equal to e to the y minus 1. Okay, so we've expanded it, and now we're going to have to go ahead and differentiate term by term. There's also a product in there, so this just becomes 2x. Using product rule implicit differentiation, I'm going to multiply 2x by the derivative of y, so we get plus 2x dy by dx, and then multiply the derivative of 2x by y, so we end up with plus 2y, and then we get minus 4 plus the derivative of this 2y dy by dx, minus 4 dy by dx. 4 disappears conveniently, at least we've got some grace there, and then e to the y differentiates e to the y dy by dx. So we have a very long derivative here, and we're going to have to try and collect stuff together. So obviously we're interested in the dy dx terms. So let's see what happens with that, shall we? So we get dy by dx, and then we put some brackets in, we get 2x plus 2y minus 4, and then on the end we get minus e to the y. So that's moved over there, and then everything else is going to move to the right hand side. So we'll start with the 4 because it's going to be positive on the right hand side, so that's gone, minus 2x. So that's gone, minus 2y. I believe that was absolutely everything. So now I've got an expression for my derivative, dy by dx. It's simply going to be equal to the right hand side and then divided through by everything under here. So over here will go under there, so we end up with 2x plus 2y minus 4 minus e to the y. Okay, so there's our derivative dealt with. So now we've got to find the stationary point. We've got to set that to 0 and solve it. So here we are again. Our derivative, we're going to set that to 0 to find the stationary point. As with any quotient, to set dy by dx to 0, we simply equate the numerator to 0, because obviously the denominator, regardless of what that is, if the numerator is 0, the whole thing becomes 0. So we end up with 4 minus 2x minus 2y equals 0, which basically divides through by 2, so we get x plus y equals 2. Now, that's a problem because it took me a little while, a bit of head scratching to figure this one out. Obviously, we've got an infinite number of solutions there. We don't have a way of pinning down our x and y. We can simply go through a series of possibilities, but that would be mathematically not particularly satisfying, and also could end up taking forever. So what I then did was I decided to, seeing x plus y was 2, I substituted that into our function. Now if x plus y is 2, then obviously this becomes 2 subtract 2 squared is 0, so that basically leads to e to the y minus 1 must also be 0. Okay, so in that case e to the y is 1, or y is equal to 0. Okay, so now we have something to work with. We can sub y back into our original expression, x plus y is 2, equation. So if I know y is 0, x is 2. So there's the coordinates of our stationary point, 2, 0. So that was the key to this question at the end. I thought I'd go through that because it was a bit of a nasty one. Thanks.